Hey everyone, welcome again to my YouTube channel. Today we are discussing about hashing algorithms. This video will give you everything you need to know about hash functions, keys, values and collision handling. So let's get started. So what exactly is hashing? Hashing is a technique that takes any size of data, could be a name, a file or even an entire book, and converts it into a fixed size value that's called a hash code. This is done by hash functions. Now, why do we need this? First, fast data retrieval. Instead of searching through thousands of records, we can jump directly to the data we need in constant time. Second, data integrity and security. Hash functions are used in password storage and verifying the files have not been tampered with. And third one is efficient storage. By organizing data intelligently, we minimize wasted space and maximize performance. Let's break down 4 core concepts you need to understand. First, hash function. This is your mathematical algorithm that does the transformation. It takes your input and produce the fixed size hash code. Think of it as a highly sophisticated calculator with a specific job. Then keys. These are the unique identifiers you are working with, like a student's name in our example or a user ID in a database. Then values. This is the actual data you want to store or retrieve, like the student's grade or a user's profile information. Then hash code is the output from the hash function. It is a fixed size number that tells us exactly where to store or find our data. And here is they work together. You take your key, pass it to the hash function and get your hash code. That hash code then points to where your value is stored. This is beautiful and simple system. Now let's see this action with a real example. Imagine you are storing student grades in a hash table with 10 slots. First, insertion. Say we want to store Alice grade. We take the key Alice. Run it through our hash function and it gives us the number 3. So we store her grade 95 at index 3 in our array. That's done. Then retrieval. Later, when we want to find Alice grade, we don't search through every student. We just hash Alice again, get index 3. Jump directly to that location and retrieve grade mark as 95. And this is the magic part. This entire operation happens in order 1 or constant time. It doesn't matter if you have 10 students or 10 million students. The lookup time stays the same. That's the power of hashing. So this is why your database can find your account among billions in milliseconds. Now here is question you might be asking. What happens when two different keys produce the same hash code? This is called as collision. Look at this example. Both Alice and Bob hash to the index 3. They both want to occupy the same spot. This is a problem. But don't worry, we have solutions. One of the most common is chaining. Here is how it works. Instead of sorting just one value at in each index, we store a linked list. So at index 3, we have Alice grade first, then Bob's grade linked after it. When we search for Bob, we hash his name. Go to index 3, then walk through the linked list until we find him. Now you might think this ruins our order 1 performance. You would be partially right. In the worst case, if everything hashes to the same index, it becomes order n. But with a good hash function, collisions are rare, and on average, we maintain near constant time performance. There are other collision handling methods too, like open addressing, but chaining is the one of the most commonly used and most straightforward. Alright, let's wrap this up with the 5 key takeaways you need to remember. First one, hashing transforms data into fixed size for efficient time. Second one, hash functions map keys to values through hash codes. Is that simple bridge. Third one is provides order 1 average complexity near instant access. Fourth one is collisions happen when different keys produce same hash code, but we have strategies to handle them. And fifth one is chaining is one elegant solution that uses linked list at each index. Now that you understand hashing, I encourage you to implement your own hash table. Start simple. Maybe store some key value pairs like we did with student grades, and then expand from there. I think this is helpful for you. So I see you in the next video. Until then, thank you for watching. Bye.